Sorry, I'm gonna just start this over. I got interrupted. So, I'll just explain it to you. So, we know that this is concept number 5, problem number 3. Okay. So, it says if 1.25 joules of work was required to compress the spring, what's the spring constant? So, we know that the work is the elastic energy. So we can use this formula, okay? And so we can substitute in 1.25 joules equals 1/2 times the constant, which is what we're looking for, times 0.05 meters squared. And so if you solve that out, it comes out to be 1,000 for the spring constant. So then we were working on B. So what is the maximum velocity of the dart after the spring has transferred its energy to it? So we know that the elastic energy, which is 1.25 joules, is all going to be transferred to kinetic energy. So we can use the kinetic energy formula. And I was just putting in the variables. So, and then times velocity squared. So then 1.25 joules equals 0.025 kilograms times velocity squared. So velocity squared equals 50 meters squared per second squared. So velocity equals 7.071 meters per second. Okay. So we're going to do C. If the dart were fired vertically, what would the height would it reach? So then if it's used this way, then at the highest point, there's no kinetic energy, so it would be all gravitational energy. So the gravitational energy equals mgh. Okay, and it's all going to be gravitational energy, so it'll be 1.25 joules equals 0.05 kilograms times 10 newtons per kilogram. Okay, so get those cancel out, times the height it reaches. So the height equals, okay, so 1.25 joules equals 0.5 newtons times the height, and so the height is equal to 2.5 meters.